So, remember from last time, we were talking about sampling and how if we have a signal that is being, if data is being delivered at a certain rate, we need to sample at the very least at an equal rate, probably faster, so that we hopefully don't lose any resolution in our data. Correct? We don't want to miss data. Then we talked about some real life examples. I think we were talking about, for instance, TV sets, refresh rate on those. And we have this idea of what can the human eye see. So we think of our eye as a measurement device. We are sampling the light from the TV set every so often. And a higher hertz rating, we talked about 60 hertz versus 120 versus 240 hertz TVs. The idea, I think you mentioned, that it should give a smoother effect. Higher hertz rating gives a smoother effect. So with the important aspect there being effect. So from a human being's perspective, when something's being delivered to us at a higher hertz rating, it's not that the image is a higher quality to us. It's because of our limited sampling rate. The chances of us missing a frame are very, very low at even 120 hertz. Okay? Well, then we had, so that would be an example of sampling rate. Well, then we used the example, we were talking about the quality of some of our screens, like on smartphones. And we were talking about like things like Retina display and some of the 4K displays. Specifically got down to the thing about Dpi, dots per inch. How many pixels can we squeeze into a single inch? The human eye can detect about 300 pixels per inch. Most of our new high quality screens that are coming out are 326 pixels per inch up to about 500 pixels per inch. So the question is, do we need that high of pixels per inch given the current state of the human eye? Will a 500 dot per inch image look better than a 300 dot per inch image will? What do we conclude along those lines? If human eye can only see 300 dots per inch, would we be able to detect the difference between an image at 326 dpi versus 500 dpi? Okay, why?
Can't remember.
What would look better about it? Okay, it comes down to more of a perception, an effect. So the more individual dots that are making up an image, technically the higher resolution of the image. I use the word resolution in terms of dots, not necessarily well, it would translate into the number of pixels, I guess. So yeah, I use the resolution as standard resolution. So given that, if we have more dots making up an image, at the very least, even if the human eye can't see the individual dots, we should have the effect of, whether you say smoother or sharper, text, for example, would be a big area, especially when you're dealing with fonts where you have curved letters, like at the letter C, for example. You know, if you looked at that really, really close at the pixel level for a font, you know, you're not going to see this smooth line. You're going to see these pixels making up that little curve. And the more pixels we have built into that curve, the smoother that curve is going to seem, right? Now, there's a point where the human eye can't detect the individual pixels, but that doesn't mean that we won't still have the perception that the curve is smoother. Does that make sense? So more DPI will equal the perception of a higher quality image. It will also equal the fact of a higher quality image, assuming there's enough data in the image. Meaning that if we have a screen capable of displaying 500 dots per inch, but we have an image, for instance, if you ever scan something in, so you have one of these scanners, usually the choice for a scanner is for text to, 75 DPI? For, then the next default might be 150 DPI, then usually 300 DPI, and that's considered photo quality, 300 DPI, because again, that's what humans can see. Then usually they'll go up to 600 DPI. Some go up to 1200 DPI or even higher for really high-end scanners. Okay? Well, so if you take an image. Let's just take a photograph. So now we're actually making a copy of a copy of a copy. So let's kind of forget about the data loss from that for a second. But let's just say we take a photograph and we scan it at 150 dpi. And then we view that photograph on a 500 dpi screen. Will it be smoother? Will it look cleaner than it would on a 326 dpi screen? Keep in mind the data that's part of that image. There's only 150 dpi worth of data if we scanned it at 150 dpi. Would it look smoother? Would it look better on 500 dpi? I'll throw another option in there. Would it look worse? 500 dpi will translate into higher resolution. So if we have a screen that's 3 inches by 4 inches, just as an example, you can figure out the resolution of that screen by the number of dots per inch. If you have 500 dpi, that means you have that's per square inch, 500 pixels in every square inch. So a 3 by 4 inch screen has how many square inches? Okay, 3 times 4 is 12. So there's 12 square inches. And we have 500 dots per square inch. So that's 500 times 12. 6,000. Does that seem right? 6,000 total dots on that screen? Well, what's a resolution of one of our smartphones? So iPhone 4S. It's 640 by 960. 640 by 960 is the resolution. Okay, so that is 6,000 or 614,000 pixels, total pixels. Now, pixels per inch for that device is 326 pixels per inch. Well, if we do the 326 pixels per inch, what's the screen size of an iPhone 4S? What are the dimensions of that screen? It's a 3.5 inch screen diagonal, right? And it's taller than it is wide. So is it probably about 3 by 4? I think it's a little bit less than that. I think it's something like 2.68 inches by 3.89 inches or something like that, some strange measurement. So where does the dots per inch come from? Because if we do that math, so we have, remember this, 614,400. Somebody remember that number. Write it down real quick. Somebody has it? Scream if you have it. No, scream. All right. So 326 pixels per inch. And if we just use the numbers again, the 3 inches wide by 4 inches tall, that gets us 12 square inches. Correct? 12 square inches. Well, if we have 326 pixels per inch, that only gives us 3,912 pixels, which is not equal to 614,400 pixels. What happens if we square that number? 3,912? Much closer number, right? This one's even bigger. Well, so what does dots per inch really mean? It's the number of pixels we can squeeze into a single pattern. So that's physical pixel size, correct? We know that the number of pixels on that screen is 640 by 960, 614,400. That's the number of total pixels on that screen. If we divide that by 326, that should get us square inches of that screen, if it's 326 pixels per inch. Do you think our iPhone is 1,884 square inches surface space? Not even the iPhone 6 Plus is going to be that, right? So what does dots per inch mean? Shouldn't if we have dots per inch, now keep in mind, it doesn't say dots per square inch, it says dots per inch. What does dots per inch translate into? So if we have, what did we say? It was 3 inches by 4 inches as an average. If we have 326 pixels per inch. So 326 times 3. So that's 978 pixels wide. That's on each line, right? How many pixels tall? So remember 978. 326 times 4, 1304. Now are we dealing with a little bit closer number? Remember, we guesstimated the 3 inch by 4 inch screen size. Right? If we know that it's 640 pixels wide, that's the resolution of that screen, and we divide that by 326, we get a width of 1.96 inches for the iPhone 4S screen. If we know that it's 960 pixels tall, we divide that by 326, we get 2.94. So 3 inches tall. Sound close-ish enough? Those numbers start making more sense, right? It's not pixels per square inch, pixels per inch. So in a single line, that's the number of pixels that fit into a single inch. Okay? So, if we have a 500 dpi screen, this is a matter of figuring out resolution. So in a 500 dpi screen, if we have the number of dots per inch and we have the physical screen size, can we then calculate resolution? If we think about this, let me do this on a slide here real quick. What's the information needed for resolution? So if this is our screen, this is our iPhone or Android computer screen, and if we know that this guy is 326 dpi, dots per inch, or ppi, pixels per inch, think of it however you want. All right? We know that. We need one of two other pieces of information to get the third piece of information. There's 3 variables here. So we have variable 1 is dpi, or ppi, pick your poison. Variable 2 is resolution, which is divided into HRes and VRes. So really 2 separate variables make up resolution. Number of pixels across, number of pixels down. Okay? And then our third physical dimensions, HDim, VDim. You can measure that in inches if you want, or you can measure it differently. You just have to convert the dots then to the right thing. So inches makes the most sense. You might say the screen is 1.96 inches wide, something like that. So these three variables go into the quality of a digital screen. Make sense? How many dots per inch can this screen display? What's the physical dimensions of that screen? Those two pieces of information then produce for us a resolution. Is that correct? So if I say, this will produce a funky resolution for us, but just to keep our numbers relatively simple, if we say that this is 2 inches, and we say that this is 3 inches, which should be close-ish to the iPhone 4S screen, right? The numbers we've been using. If we have those physical dimensions, what's the formula for figuring out resolution? So we have 326 dpi, we have that variable, and we also have the horizontal and the vertical physical dimensions. What would the formula be for figuring out resolution from those variables? I want to get that number like 640 by 960. It won't be exactly that in this model, but those kinds of numbers. How do I calculate that 640-ish number?
With times dpi.
Okay, so this number in inches multiplied by this number. So HRes is equal to dpi times HDim in inches. Put a little parenthesis. That makes sense? So in this example, that's 326 times 2. 652. Okay. And then VRes is dpi times VDim in inches, which will be 326 times 3, which is 978. So, given these physical dimensions and that dpi, we have a resolution of 652 by 978. That make sense? Okay, let's say that we know these numbers. So we'll just put it above here. 652 978. Given those numbers, how do we calculate physical dimensions? How do we get the 2 and the 3? So HDim is equal to what? You said the 652, which our variable name for that is HRes. So that's HRes divided by dpi, which should be 2 in this example, right? And VDIM is VRES divided by DPI, which should be 3. Now, what if we have the resolution and the physical dimension, but not the DPI? How do we calculate DPI? So if we have DPI, if we have everything but DPI, and we want to calculate DPI, what's the formula look like? You got this. Come on. All right. I had to pump myself up there. Sometimes you get a little. What's formula for DPI? HRES divided by HDIM. So 652 divided by 2 gives us DPI. Okay. Or, it's another measurement. Ooh, hello. DPI is also equal to what? VRES? VDIM? Okay. So now that we have a bunch of formulas, could we write a converter for that? Given any two variables, we can solve for the third. Okay, now I'm going to start, we're going to kind of go into our code here. And I'm going to break this down a little bit because our converter guy's getting a little bit beefy at this point. All right, so we're going to write our own object for, I don't know, we'll call it, what do we want to call it? Screen info. How about that? Screen info object. That makes sense. So I'm going to right click here. We're going to say new class. We'll call this guy screen info. And screen info is going to keep track of 3 pieces of information. All right. We're going to keep track of we'll probably want them as doubles because sometimes you won't have a screen dimensions equal to a certain thing, right? So we're going to say double. Actually, we'll have 6. 1, 2, 3, 4, 5. 5 pieces of information. So we're going to have double DPI. We're going to have double HRES. We're going to have double VRES. We'll have double HDIM. And we'll have double VDIM. And as good programmers, and I know you 250 people haven't seen this before, but we'll make these all private. So we can only modify those internally here. All right, now, when we create a screen, in fact, actually, yeah, we'll leave it called screen info, that's fine. When we create a screen info object, we have to create it with at least 2 of these pieces of information, correct? And then we can solve for the third. Is it possible to create a screen info object with only 1 piece of information? If we have DPI only, can we figure out HRES, VRES, HDIM, and VDIM? If all we have is DPI. We can run a simulation and come up with some guesses, right? Keep trying values until we get something that hits that looks like a resolution-y type thing. What's another measurement for screens that might help us? We're not going to use it in this example, but there's a kind of a fourth well, I guess in this case, a sixth piece of information, sixth and seventh piece of information. How many of you heard of aspect ratio? What's an aspect ratio? What does that mean? For instance, standard definition TVs typically have a what aspect ratio? 4:3. High definition TVs, 16:9. So it's 16 wide by 9 tall as a ratio. Does that make sense? Big screen TVs tend to be widescreen, right? They are wider than they are tall at the ratio of 16:9. Same thing, standard definition is 4:3. So if you had DPI and an aspect ratio, both horizontal and vertical, could you make a reasonable guess at the other 4 variables? It would only be a guess, right? Because you could keep doubling it, correct? Aspect ratio just tells you the ratio of width to height. So you don't know if it's 1,000 by 500 or 2,000 by 1,000. You know what I'm saying? You're making a guess of exactly the density of it. So we won't go that deep, but just another thing to kind of consider is aspect ratio. But for our purposes right here, we need either DPI plus HRES plus VRES, or we need DPI plus HDIM and VDIM, or we need HRES, VRES, HDIM, VDIM. Those are the 3 different scenarios that we need in order to figure out all the variables. Correct? So we're going to write 3 different constructors. So those of you who are in 250, remember earlier today I said everything's always connected, right? Okay. We're going to create a constructor here, so you haven't done this in 250 yet, but the rest of you have done it before. But we're going to create 3 of these. What's it called when we have 3 different methods with the same name but a different number and or type of parameters? Polymorphism. So we're going to create 3 different constructors. There are 3 different dudes that can build a screen info object for us. Each dude requires a different collection of information in order to properly build it. All right? So first dude, or dudette, is that still a word, dudette? That's an 80s term, I think. Never heard it. Never heard it. All right, so we're going to say public screen info, and we're going to write the one that takes in a double DPI, a double HRES, and a double VRES. So given those pieces of information, we're going to set our fields, DPI, HRES, and VRES equal to what was passed in, and then we're going to calculate HDIM and VDIM with the formulas we've figured out. All right? So we'll say this dot DPI is equal to DPI. And just as a super, super tiny quick lesson for those of you who are in 250, just foreshadowing, this dot DPI says we're accessing this variable up here, the one that belongs to this object. DPI is this one because all variables always resolve to their most local definition. So DPI resolves to the most local definition of it. In order to access this guy up here, we had to specify that it's the DPI owned by this dude to bypass its default local definition resolution. So this dot DPI is equal to DPI. This dot HRES is equal to HRES. This dot VRES is equal to VRES. Now we need to calculate HDIM. This dot HDIM is equal to what? What's the math for HDIM? Go back to our slide. HDIM is equal to HRES divided by DPI. This dot HRES divided by this dot DPI. That gives us our HDIM. This dot VDIM is equal to this dot VRES divided by this dot DPI. So now we've calculated for all of those values. It's So let's test this on a small scale real quick. So we're going to create a quick little method called display. And this guy just displays the dimension and displays the information about this screen. So we'll say system.out.println DPI colon this dot DPI. So we'll print out the DPI. Resolution. And we'll print out the resolution. And the resolution is going to be this dot hrez concatenated by a space x space concatenated this dot vrez. So that'll build a nice thing like resolution colon 960 or like what was it 640 x 960. We'll put those strings together. And finally, I'll just write it. System.out.println. Minimize this some more. This shows up on the screen. Physical. Man, that's a weird. Physical. There we go. Is this dot h dim. And we're going to do this in inches, so we'll say inches by this dot vdim. Actually, I think I want a space in there. It'll look cleaner with a space after the number before the word inches. All right. So when we ask this object to display itself, it's going to give us the quick rundown of this particular screen. All right. So we'll test this on our 4S real quick. We'll go into converter. I'm sorry, not converter. We'll go into test, which is where our main is. We'll delete all this extra crap. And we're going to go ahead and create a screen info object called SI is equal to new screen info. And we only have one constructor for this guy. The constructor we wrote requires us to pass it the DPI, the H resolution, and the V resolution. So I'm going to pass in 326 for the number of DPI for a 4S. Then I'm going to pass in 640 for the H resolution. Then I'll pass in 960 for the V vertical resolution. And then I'll say SI dot display. And this should give us the physical, well, this should give us all the information about a 4S. DPI is 326. Resolution is 640 by 960. Physical is 1.96 inches by 2.94 inches. Make sense? Okay. Now we have a couple of other, actually, just out of curiosity, let's try this with the specs from another device. So let's do the iPhone 6 Plus. So that guy, I think, was it 400 or was it 401 DPI? Let's look it up real quick. This will probably give us the info we need. Oh, very pretty. Give me the specs. Okay, well that's the resolution, 1920 by 1080. Does it tell us the, I might have to click more info up here.
Yeah,
401 pixels per inch. All right, so we'll do 401 pixels per inch. Then we have 1080 is the horizontal. 1920 is the vertical. So we're actually kind of giving our resolutions backwards a little bit. Typically it's, like they say 1920 by 1080, so they're giving the width, the other width. Get it? As long as we're consistent, it's not the end of the world. All right, and this should give us a physical dimension of that device. So 2.69 inches wide, 4.78 inches tall for the screen. Now, do we have somewhere on the iPhone site the physical dimensions of the screen? It's got to be like tech specs. Well, real quick, we can do this. We can solve for the hypotenuse, which should be 5.5, right? A squared plus b squared equals c squared. So we should be able to say 2. I'm just going to actually display it out here. 2.69, 4.79. 2.69, 4.79. What did I say, 3.79? 4.79? So that's the two things. And we want math dot square root of that. So pretty close to 5.5, would you say? I left out some decimal places in our math. Seems to be legit. Okay, so we've probably come up with a pretty, in fact, actually, here, this is a, why not solve for vertical? That should go into our screen info, right? So let's do private double, what would you call this, just screen size? Would you say that 5.5 inch number is screen size? So screen size. So as in our constructor, we want to solve for screen size. So this dot screen size is equal to math dot square root of math dot pow of this dot hdim to the second power plus math dot pow of this dot vdim to the second power. So that's the screen size. And then we'll print, so we solved for it in the constructor, and then we'll display it in our display. System.out.println screen size, this dot screen size. Inches. Okay, so we solved for one additional value, and then we'll print out one additional value. So here's our iPhone 6 Plus. And there's our 401, 1080 by 1920. We'll go ahead and flip those around just so it's a little bit more traditional, because it's usually given as 1920 by 1080. Then physical size is this, screen size is this. So let's go ahead and flip around those, the resolution. So we're going to say VRes here and HRes here. And then let's just make sure our dimensions match up. VDim and HDim. We haven't done anything different, just our display is a little bit more traditional as to how resolutions are given. It'll be 1920 by 1080 instead of 1080 by 1920. One's not more accurate than the other one, as long as you know what the 1080 means and what the 1920 means in terms of which dimension. And so let's take a device like the Note 4, Galaxy Note 4. I believe that guy is 500 DPI. I think that's the number. What's the screen resolution? I know it's a 4K screen. What did we decide 4K was? Let's see, Galaxy Note 4 screen resolution. Okay, it's 2560 by 1440. So this number for ours is 1440. This number is 2560. I think it's the 500. I think that's right. That gives us a screen size of 5.87. Yeah, 500 pixels per inch. They list it as a 5.7 inch screen. $560. So actually, given that, one of these numbers must be a lie. It's probably the DPI. So my guess is the DPI is something like let's try 490. Because they're saying it's a 5.7 inch screen. Oh wait, hold on, I'm going the wrong direction. Why is that right? Wait, why is that? Why is higher DPI at the same resolution? Oh, that makes sense. If you're squeezing more pixels into a smaller footprint, you're going to get a smaller value. So 515 compresses those, which is actually interesting. So mathematically, the Galaxy Note 4 is, if we treat this as 5.7, which it looks pretty close, should have about a 4.97 inch height, a 2.8 inch width, and that's the resolution. So it's actually 515 DPI. Why wouldn't they say that? If you're a company and everybody else is, like the iPhone is 401 DPI, which is better than 400, right? And you're Samsung and you have something that's 515, why would you say 500?
Apparently they're just quietly awesome about it.
If that's true, that's impressive.
It's so awesome, it just doesn't need to be said.
Yeah, no, I mean, seriously. If that's true, that's actually somewhat impressive that a company would underplay. Unless there's something with the resolution where these numbers are actually a little bit off. But it seems more likely that they would lie about this being high than lie about this being low, doesn't it? I just can't imagine them saying it's 500 DPI when it's actually 515. I can see them saying it's 2560 by 1440 when it's actually 2551 by 1436 or something like that. I can see that being true. In fact, actually, let's 1433 by 2551. It's getting closer. So, I don't know. Very interesting. But then again, I'm thinking about it from a developer perspective. That resolution is actually very important that that's accurate. Because when you build graphics for this, you're going to build graphics at the appropriate resolution. So if they fudge that number, it actually hurts your graphic alignment. So, I don't know. Logic would say they're lying about these numbers, but logic would also say they're lying about that number on the low side. Very interesting. It'll be interesting to see when it actually finally ships, if they update the numbers. Yeah, maybe they're working on the screens right now, and all they wanted to claim was 500 DPI. I don't know, but just kind of an interesting thing. So quick question actually related to this. Why wouldn't every new phone pack more pixels? We see that, let's just say it's 515. We see that 515 pixels per inch is possible. Well, why doesn't the iPhone 6 Plus have 515? Why doesn't the iPhone 6 have 515? iPhone 6 actually has 326. Where the iPhone 6 Plus has 401. Why? Is it more pixels per inch better? What do you think? Shouldn't you always want the more pixels per inch? What if we had 515 pixels per inch on the iPhone 4S? So we're going to go back to our resolution. So what was the resolution? The resolution was 640 by 960 at 515 pixels per inch. Exact same resolution, higher pixels per inch. We get a physical dimension of 1.86 tall by 1.24 wide with a vertical screen size of 2.2 inches. Let's give it the benefit of that, 2.24 inches. How many of you would buy a phone with a 2.25 inch screen? If you watch the Apple Watch keynote thing, and they were talking about how the touch screen stuff doesn't really make sense, that was probably a 2.25 inch screen. What they were showing, I bet you that's probably pretty close to the horizontal of the Apple Watch, something like that. Maybe it's 2 or 1.8, but something in that ballpark. So more pixels per inch at a fixed resolution becomes a problem. Well, so why don't we just double the resolution? We like high resolution, right? So we'll do this 1280 by 1920. Same aspect ratio, just twice the number of pixels. 4.4 inch screen, that's more reasonable, right? Wouldn't we love that? What's the problem with that? The technology exists. We can squeeze 515 pixels per inch into these devices. Why wouldn't we do it? Remember last class we went down and looked at the 4K monitor down there? It's kind of unusable, right? Why? That was a 32-inch monitor. What if it was 64 inches? Would it be more usable at 64 inches? I think it probably would be. Yeah, you'd have to turn your head a little bit more, but I think from a resolution perspective, you would be able to control the mouse better. At that screen size, I mean, we don't think of a 32-inch desktop monitor as being small, right? But at that screen size, packing that many pixels onto it made it very difficult for us to work with. So now you take this little tiny screen. Everything's going to be super tiny on it, right? You'll be hitting icons next to each other because your fingers are too fat. We already have the complaint about the fat finger, right? You know, with the keyboards. People don't like the touch keyboards, and that was why BlackBerry stayed around for so long, because of the physical keyboards. You know, then Androids, you know, you had Android phones coming out for a while that had the slide-out keyboard, and that was supposed to be cool. Nobody talks about those anymore, do they? Well, but that was supposed to be better. It's like, oh, well, we have a physical keyboard. So get the Android phone that's twice as thick with a physical keyboard on it, and that's supposed to be better. And Android people used to brag about it, right? But they quietly dropped that. Nobody makes those anymore, unless they don't want to sell a phone, right? But then what did BlackBerry do? They started coming out with BlackBerries that just had touchscreens instead of the keyboard. Now that pissed BlackBerry users off. You know, the only rational reason to stay with BlackBerry is because of the keyboard, right? Period. There's no other reason to be using BlackBerry today, even if your company gave you the phone. Like, here's a free phone. No, thank you. I'd like to actually have apps.
I bring that in somewhere.
Yeah. Like, is there like, did you give us like an allowance, like $20 towards our monthly bill or something like that? Okay, so just because we can squeeze more pixels per inch onto a screen doesn't necessarily mean we should. So now we get over to that 4K display on the Note 4. So start talking about the comparison. Since the iPhone 6 Plus was announced, you know, you've seen a lot of people online. You know, this always happens, right? You have the Apple bashers and the Android bashers, and it just goes back and forth, right? It's a lot of fun, and people make the fun videos. I think you referenced one of them unknowingly this morning when you said,
oh, I know that. Yeah.
Yeah, you watched the.
I've seen that video.
Yeah. So I did catch that, by the way. You know, there was some video out there about what what Apple should have announced, what features they should have announced for the new phone or something like that. It was entertaining. It was a funny video. But people who are looking at the 6 Plus and seeing, okay, well, it's 1920 by 1080 resolution. It's 401 dots per inch. They're looking at this other Samsung Galaxy Note that comes out like in a month. So let's just say they roughly come out at the same time. I mean, don't want to hold a month against them, right? So we're going to say they're modern technology from both of these companies. Yet the specs, from specifically the screen, at a glance, the specs on the Note 4 look superior in pretty much every way. More dots per inch, higher resolution. They got the 4K buzzword going, right? Isn't that the screen buzzword today? It's like, well, mine's 4K, whatever the heck that means. Okay, yeah, we've looked at the resolutions, fine, whatever.
Gotta have that LED too.
Okay, but it's the buzzword. Well, LED versus what? I mean, they're both LED technologies. Just one of them uses one type of pixel doubling. The other one uses a different type of pixel doubling.
Can't hit on plasma too much.
No. I mean, you're right. But I mean, if you look at the specs,
yeah,
you would agree that most people, consumers, would look at the two and say, okay, something's not adding up here. Isn't Apple awesome? Isn't Apple, this is their new product? Aren't they supposed to come out with their latest, greatest, coolest stuff? Why does this device that's coming out at the same time, let's say, why does it have so much better specs? So the question for you is, as technologists, is it really better? It's definitely not fair to say it's worse. But now that you know some of the stuff, what's the difference between those two devices from an end user experience? Screen size is going to be roughly the same, right? About 2.2 inches difference. So roughly a similar experience. The phablet experience, right? Big screen size, okay? That's the phone tablet for, probably you. Do you know what phablet meant? I figured not. Because you heard tablet, right?
Yeah.
And you heard phone. Okay, it's phablet. Put them together. It's a big. You with us now? Yeah. There you go. Yeah. So we're going to call them the same size device. Which do you want? Let's just assume they're both running your favorite operating system. If you're an iPhone user, the Android one's running the iPhone OS, if that's the one you like. If you're, an iPhone user or you're an Android user, the 6 Plus is going to run Android. So don't play the operating system into it. Which piece of hardware do you want? And why? What's the downside of the Note 4? Go ahead.
Either all the graphics and their placements need to be updated for the increased resolution, or everything's going to be really tiny.
Okay. Well, so the first part of what you said is probably going to be true of either device, because this is a new resolution for. If you're running iOS, this will be a new resolution for iOS, and Apple has claimed they have this new software pixel doubling thing that is supposed to be superior, supposed to be better. Historically, Apple's done pretty well with that. That's a conversation we can have related to cameras. For those of you who do a lot of photo stuff, that's another comparison you look at. You look at the camera on the Galaxy 4, the Galaxy Note 4, and it has a lot higher megapixels, right? More megapixels means more better, right? Clearly. If you had $500 to spend, you spend $500 on a camera with 20 megapixels, or you can spend the same $500 on a camera with 14 megapixels. Which would you get? 20 megapixels, because it's better. Is it better? Depends what else is going on with the camera. Lots of other things play into that. You have optics. I'm not a photographer, but these are the things I know about. You have optics. You have, the aperture of the lens, how often it opens, what kind of exposures can you take. All sorts of different things that have very little to do with the amount of data they can stuff into an image. Okay, does that make sense? So something that we've seen in the past with iPhone cameras and cameras from other companies is many times the iPhone has won awards for like best smartphone camera. I mean, we're not going to compete with the DSLR, super expensive, I'm a professional photographer, I don't take pictures with my cell phone guys, right? But for cell phone cameras, we're talking pretty good quality. But almost every single year, Apple releases what they call their EyeSight camera, right? That has a substantially lower megapixel rating than the comparable competition on the Android side. Yet Apple very often is, at the very least, right up top with the competition. They're not like getting beat for when somebody views the actual images produced by the camera. They're producing good images. Apple is very reliant on software for enhancing their image taking, as opposed to just high megapixels. Now, that doesn't mean that there are some cameras that, some phones on the Android side, or specifically there was a Windows phone that built very high-end hardware into the camera. Phone may have sucked, okay? But it was, for a smartphone, it was taking good pictures because it had a lot of optical zoom. It wasn't doing it in software. It had a physical, it wasn't going to fit in your pocket that well because it literally zoomed out. I mean, it had, it had a lens on it. But sometimes there's more than meets the eye to this technology stuff. So something you mentioned is everything's going to be really tiny on that Galaxy screen. So unless they start updating the apps, let's say you digest a lot of your, I'm going to talk about it as a worst case scenario. Let's say you digest a lot of your news through a mobile web browser. So on Android, it would be Chrome, right? Nothing wrong with Chrome. Chrome web browser is perfectly fine. Safari on iOS, perfectly fine. Let's just call them the same. Comparable web browsers, okay? By default, the text is going to be super tiny on that the Galaxy Note 4 because of how many pixels they've packed onto that screen. It'll be super sharp text. But I would say that there are going to be people that are going to struggle digesting their news through websites on those. Well, then you can go over to the apps. Well, apps that haven't been built for that are going to suffer from blurry text because Android doesn't have the pixel doubling technology yet that Apple's using. They will. Give them 3 months and they'll take what Apple's done and they'll duplicate it just like Apple duplicated stuff from Android. Those of you who are Android users, you've been bragging about swipe for keyboards for 2 or 3, 4 years, right? Finally, Apple is allowing third parties to make keyboards. This is 4 years in the making, right? Not everybody's going to like every keyboard, but at least now a third-party developer can write their own keyboards for iPhone. So day 2, you're going to have somebody who's going to come out with the equivalent. It's called swipe, right? Yeah. You're going to have the equivalent of the swipe keyboard for Apple. Probably have 30 of them. 30 people making those. And then you'll have people come up with other keyboards and stuff like that. But, both of these companies steal from each other. They just keep one-upping, figuring out a cool technology. So, give Google a couple of months or something. They'll kind of see what Apple's done with their pixel doubling technology, and then they'll do it. So the Galaxy Note isn't going to be this, this crap product. But it might suffer early on, assuming it comes out in about a month. It might suffer early on because the hardware is too new and the apps haven't caught up. So you take like the USA Today app on Android, which is already actually kind of a weak app. If you look at USA Today on Android versus iPhone, it's a substantially less polished product, and it's also not made for a lot of different screen sizes. So now we're going to take that app and we're going to throw it on the latest, greatest, coolest Rolls Royce of Android devices. And it's going to look okay, but what's going to happen is the interface that was meant to be this big is just going to be tripled in size to this, but without the software to really, kind of meld the pixels together to kind of make a smooth transition. It's just going to look it won't look pixelated because you won't see the pixels. It'll look blurry. Does that kind of make sense? Not to the point of being garbage. Okay. The text will look very nice. You'll be able to read it. It'll be plenty big and stuff like that, but it just won't look like it was made for that device. But for applications where you do have them made for that device, so very likely when it ships, it'll ship with a version of Android that has taken that resolution into consideration. So it very likely will have a version of Chrome that has taken it into consideration. And the hope is that they give you the ability to blow up the text. Otherwise, we'll have the same problems we had down the hall last class. We had to max out Safari, for the handicapped so we can see it, right? Otherwise, it would have been unusable. So, these are interesting things to consider when it comes to new technology. A lot of times you can't just compare the specs. Specs don't necessarily mean anything. Faster processor doesn't mean better. Right now it's all a mystery with the iPhone 6 and the 6 Plus that have the Apple's A8 chip that they make. Apple's told us nothing about its speed, and anything it today tells us about its speed will be meaningless. Let's say that Apple comes out and says that the A8 chip is running at 1.6 gigahertz. I know the Galaxy Note 4 is running one of the Snapdragon chips. Let's say it's at 2.2 gigahertz. I'm just putting it a little faster. I don't know what the actual number is. Does that mean that the Snapdragon is faster than the A8 chip? No. It could be slower in every way. More than likely, it's probably slower in some ways and faster in others. Usually when you deal with different architectures and chips, some of them are very good at specific things, other ones are very good at other things, and they lack in some other area. So even at that level, you can't compare the two because you're not comparing apples to apples, pun intended. Okay? That doesn't mean that the A8 chip is worse or better or worse than the Snapdragon. They're both based on ARM technology, ARM processors, which is a reduced instruction set type thing, which we'll talk about later on this semester when we talk about assembly language. But, you know, the specs are very difficult for comparing things. So one thing I kind of wanted to get across today as we're going through this is kind of the more you know, right? I mean, have we learned stuff today about how DPI plays into screen densities and what it actually means when it comes to the actual device? Where before this, most of it was just buzzwords they throw on the screen to sound cool. You know, but this is really interesting stuff because there's a difference between high resolution and end user experience. That monitor down there from a spec perspective is awesome. It's completely sick. From a user experience, it's unusable. You have to drop it to 1080p basically, to 1920 by 1080 for it to have an end user experience that's reasonable. If that's the case, why didn't we just buy a 1920 by 1080 monitor to begin with and then make a year's worth of car payments for the rest of the money we didn't spend on the monitor? See what I'm saying? These become very interesting things. So faster, more resolution, higher pixel density doesn't always mean better. You know. Now, having said that, how many of you would buy a device today, a new smartphone from any company, that had less than 300 DPI? Why not? Out of curiosity, does anybody in here have a iPhone 3GS or older? 3GS. I think you have a 4S.
No, I have them in my room.
Oh, okay.
I used to use it though. Before I got this.
Does it still work?
Yeah, it still works.
You should look at the screen when you get back there and you can see the pixels. You'll see the difference.
It's awful.
Yeah. Well, but specifically look for the pixels. You'll actually see what this DPI we're talking about is. Why wouldn't you buy a phone that had less than 300 DPI?
So they can't do 300 DPI. The rest of it's probably pretty shit too.
so the argument is if they can't do 300 DPI, then they're probably not doing much else. Okay, the better argument probably, which that's probably not inaccurate, but the better argument is, well, we'd at least like to take full advantage of our eyes, right? We have seen from these numbers that at 300 DPI, screen sizes are within the realm of reasonable for a smartphone, correct? We're not at that 1.7 inch screen. We're at a reasonable screen size, 3.5 or 4 inch horizontal, that kind of stuff, or diagonal rather. So we might as well take full advantage of what our eyes can measure as an instrument, correct? And that was something we talked about last time. That's not a sampling theory. That's not a sampling rate problem. You know, it's not how fast our eyes are looking at those pixels. It's our ability to distinguish one pixel from another. When you get too many pixels tightly packed, we can't tell them apart because our eyes are only so good at seeing. The instrument has its limit. So it makes perfect sense today to say, I'm only going to accept something that's 300 DPI or better. So when you look at the iPhone 6 versus the iPhone 6 Plus, just using those as our examples, these are two brand new phones from Apple. One of them is 326 DPI, which is the same pixels per inch as the previous iPhone, and the previous iPhone to that, and the previous iPhone to that. And the 6 Plus is 401 pixels per inch. 401 isn't necessarily better than 326. The reality is because of the bigger screen size, they probably scale about equivalently. Does that make sense? So why didn't Apple, what might one reason be that Apple didn't jump to the 500 or 515 pixels per inch? We know the technology exists. One reason might be they may have decided that was too many pixel screens on the screen. Another reason certainly could have been that when they settled on the screen and started integrating the product, the 500 pixel per inch screens weren't being produced, or they couldn't produce them in large enough quantity. That might be an interesting thing when we see when the Galaxy Note 4 first starts shipping, if they're in very limited quantities, because that is a pretty substantial, from a technology perspective, a very substantially, well, a much better screen technology than is in any phone right now. It's a pretty big jump. So I wonder if they're going to have some problems producing it in quantity for a period of time. It'll be interesting to see. Homework. I'm going to give you our screen info. I want you to write the rest of the constructors, our other two constructors. That is the constructor that takes in DPI, HDIM, VDIM, and also the one that takes in HRES, VRES, HDIM, VDIM, and calculates the other values. So you're going to write this guy 2 more times and do the formulas for the rest of them, and you won't have to touch display because it'll just work.
Won't you have problems if you do one with just another 3 doubles?
No. It's got different.
I understand what you're saying. I understand what you're saying.
Because it's going to interpret that as the same.
Yeah. That's a good point. It's actually a very good point.
Number and type of parameters is the same.
True.
All right. He brought up a point. We'll talk more about that next time. For your homework, just write the one that takes in the 4 doubles and solves for DPI. Because the issue you're going to run into is if you write another version of this that takes in 3 doubles, even though you're taking in DPI, HDIM, and VDIM, it won't be able to distinguish from this one. Because it doesn't care that the variable names are different. It cares about the types and number of variables. So you're just going to write one additional constructor, the one that takes in 4 doubles and solves for DPI. That make sense? Okay, and I'll give you this code as a starting point. No, you can. There's a workaround. I just didn't want to, with no time left, I don't want to have to explain. We'll just do it next class.